In logic, the law of excluded middle is the third of the three classic laws of thought. It states that for any proposition either that proposition is true, or its negation is true. The law is also known as the law of the excluded third, in Latin principium tertii exclusi. Yet another Latin designation for this law is tertium non datur, no third is given. The earliest known formulation is Aristotle's principle of non-contradiction, first proposed in On Interpretation, where he says that of two contradictory propositions one must be true, and the other false. He also states it as a principle in the Metaphysics Book 3, saying that it is necessary in every case to affirm or deny, and that it is impossible that there should be anything between the two parts of a contradiction. The principle was stated as a theorem of propositional logic by Russell and Whitehead in Principia Mathematica as. The principle should not be confused with the semantical principle of bivalence, which states that every proposition is either true or false. Classic laws of thought, the principle of excluded middle, along with its complement, the law of contradiction, are correlates of the law of identity. Analogous laws, some systems of logic have different but analogous laws. For some finite n-valued logics, there is an analogous law called the law of excluded n+1th. If negation is cyclic and A is a max operator, then the law can be expressed in the object language by, where represents n1 negation signs and A and n1 disjunction signs. It is easy to check that the sentence must receive at least one of the n-truth values. Other systems reject the law entirely. Examples: for example, if P is the proposition, Socrates is mortal. Then the law of excluded middle holds that the logical disjunction, either Socrates is mortal, or it is not the case that Socrates is mortal, is true by virtue of its form alone. That is, the middle position, that Socrates is neither mortal nor not mortal, is excluded by logic, and therefore either the first possibility or its negation must be true. An example of an argument that depends on the law of excluded middle follows. We seek to prove that there exist two irrational numbers and such that is rational. It is known that is irrational. Consider the number. Clearly this number is either rational or irrational. If it is rational, the proof is complete, and. But if it is irrational, then let, and. Then, and 2 is certainly rational. This concludes the proof. In the above argument, the assertion this number is either rational or irrational invokes the law of excluded middle. An intuitionist, for example, would not accept this argument without further support for that statement. This might come in the form of a proof that the number in question is in fact irrational, or a finite algorithm that could determine whether the number is rational. Equals the law in non-constructive proofs over the infinite equals. The above proof is an example of a non-constructive proof disallowed by intuitionists. The proof is non-constructive because it doesn't give specific numbers and that satisfy the theorem but only two separate possibilities, one of which must work. By non-constructive Davis means that a proof that there actually are mathematic entities satisfying certain conditions would have to provide a method to exhibit explicitly the entities in question. Such proofs presume the existence of a totality that is complete, a notion disallowed by intuitionists when extended to the infinity. For them the infinite can never be completed. In classical mathematics there occur non-constructive or indirect existence proofs, which intuitionists do not accept. For example, to prove there exists an n such that P, n, the classical mathematician may deduce a contradiction from the assumption for all n, not P, n. Under both the classical and the intuitionistic logic, by reductio ad absurdum this gives not for all n, not P, n. The classical logic allows this result to be transformed into there exists an n such that P, n, but not in general the intuitionistic. The classical meaning, that somewhere in the completed infinite totality of the natural numbers there occurs an n such that P, n, is not available to him, since he does not conceive the natural numbers as a completed totality. Indeed, Hilbert and Brough both give examples of the law of excluded middle extended to the infinite. Hilbert's example, the assertion that either there are only finitely many prime numbers or there are infinitely many. And Brough's, every mathematical species is either finite or infinite. In general, intuitionists allow the use of the law of excluded middle when it is confined to discourse over finite collections, but not when it is used in discourse over infinite sets. Thus intuitionists absolutely disallow the blanket assertion, for all propositions P concerning infinite sets D, P or P. For more about the conflict between the intuitionists and the formalists, see Foundations of Mathematics and Intuitionism. Putative counterexamples to the law of excluded middle include the liar paradox or Quine's paradox. Certain resolutions of these paradoxes, particularly Graham Priest's dialetheism as formalized in LP, have the law of excluded middle as a theorem, but resolve out the liar as both true and false. In this way, the law of excluded middle is true, but because truth itself, and therefore disjunction, is not exclusive, it says next to nothing if one of the disjuncts is paradoxical, or both true and false. History Aristotle wrote that ambiguity can arise from the use of ambiguous names, but cannot exist in the facts themselves. It is impossible, then, that being a man should mean precisely not being a man, if man not only signifies something about one subject but also has one significance. And it will not be possible to be and not to be the same thing, except in virtue of an ambiguity, just as if one whom we call man, and others were to call not man. But the point in question is not this, whether the same thing can at the same time be and not be a man in name, but whether it can be in fact. GBWW 8, 525 Euro 526. Aristotle's assertion that it will not be possible to be and not to be the same thing, which would be written in propositional logic as is a statement modern logicians could call the law of excluded middle, as distribution of the negation of Aristotle's assertion makes them equivalent, regardless that the former claims that no statement is both true and false, while the latter requires that any statement is either true or false. However, Aristotle also writes, since it is impossible that contradictories should be at the same time true of the same thing, obviously contraries also cannot belong at the same time to the same thing. He then proposes that there cannot be an intermediate between contradictories, but of one subject we must either affirm or deny any one predicate. In the context of Aristotle's traditional logic, this is a remarkably precise statement of the law of excluded middle, PAP equals Leibniz equals. Its usual form, every judgment is either true or false, footnote 9. From Kolmogorov and Van Heijnout, pages 421, footnote 9, this is Leibniz's very simple formulation. Equals Bertrand Russell and Principium Mathematica equals, Bertrand Russell asserts a distinction between the law of excluded middle, and the law of non-contradiction. In the Problems of Philosophy, he cites three laws of thought as more or less self-evident, or a priori in the sense of Aristotle. 1. Law of identity, whatever is, is. 2. Law of non-contradiction, nothing can both be and not be. 3. Law of excluded middle, everything must either be or not be. These three laws are samples of self-evident logical principles. It is correct, at least for bivalent logic that is it can be seen with a Carnot-Mappard that Russell's law removes the middle of the inclusive or used in his law. And this is the point of Reichenbach's demonstration that some believe the exclusive or should take the place of the inclusive or. About this issue Reichenbach observes. The tertium non-data, 29. F, X, AF, X, is not exhaustive in its major terms and is therefore an inflated formula. This fact may perhaps explain why some people consider it unreasonable to write with the inclusive or, and want to have it written with the sign of the exclusive or. 30. F, X, F, X, where the symbol signifies exclusive or, in which form it would be fully exhaustive and therefore nomological in the narrower sense. In line the X means for all, or for every, a form used by Russell and Reichenbach. Today the symbolism is usually X. Thus an example of the expression would look like this, pig, flies, pig, for all instances of pig seen and unseen. A formal definition from Principium Mathematica, Principium Mathematica defines the law of excluded middle formally. 2.1 PAP, example, either it is true that this is red, or it is true that this is not red. Hence it is true that this is red or this is not red. So just what is truth, and falsehood? At the opening PM quickly announces some definitions. Truth values. The truth values of a proposition is truth if it is true and falsehood if it is false. This phrase is due to Frege. The truth value of PAQ is truth if the truth value of either P or Q is truth, and is falsehood otherwise. That of P is the opposite of that of P. This is not much help. But later, in a much deeper discussion, PM defines truth and falsehood in terms of a relationship between the A, and the B, and the percipient. For example, this A as B really means object A is a sense datum, and red is a sense datum, and they stand in relation to one another and in relation to I. Thus what we really mean is, I perceive that this object A is red, and this is an undeniable by third-party truth. PM further defines a distinction between a sense datum, and a sensation. That is, when we judge this as red, what occurs is a relation of three terms, the mind, and this, and red. On the other hand, when we perceive the redness of this, there is a relation of two terms, namely the mind and the complex object the redness of this. Russell reiterated his distinction between sense datum and sensation in his book The Problems of Philosophy, published at the same time as PM. Let us give the name of sense data to the things that are immediately known in sensation, such things as colors, sounds, smells, hardnesses, roughnesses, and so on. We shall give the name sensation to the experience of being immediately aware of these things. The color itself is a sense datum, not a sensation. Russell further described his reasoning behind his definitions of truth and falsehood in the same book. Consequences of the law of excluded middle in Principium Mathematica, from the law of excluded middle, formula or 2.1 in Principium Mathematica, Whitehead and Russell derive some of the most powerful tools in the logician's argumentation toolkit, or 2.1 PAP. This is the law of excluded middle. The proof of or 2.1 is roughly as follows. Primitive idea 1.08 defines PAQ equals PAQ. Substituting P for Q in this rule yields PAP equals PAP. Since PAP is true, then PAP must be true. Or 2.11 PAP, or 2.12 PAP, or 2.13 PAP, or 2.14 PAP, or 2.15, or 2.16, or 2.17, or 2.18 AP. Most of these theorems are in particular or 2.1, or 2.11, and or 2.14 are rejected by intuitionism. These tools are recast into another form that Kolmogorov cites as Hilbert's 4 axioms of implication, and Hilbert's 2 axioms of negation. Propositions or 2.12 and or 2.14, double negation. The intuitionist writings of L. E. J. Brough refer to what he calls the principle of the reciprocity of the multiple species, that is, the principle that for every system the correctness of a property follows from the impossibility of this property. This principle is commonly called the principle of double negation. From the law of excluded middle, PM derives principle or 2.12 immediately. We substitute P for P in 2.11 to yield PA, P, and by the definition of implication then PA, P, equals PA, P. QED. Using computer science proofs, the law of excluded middle can be used to prove the decidability of certain computational problems. Usually, decidability is proved by showing an algorithm that solves the problem. However, in some cases it is possible to prove that a problem is decidable without showing an algorithm that solves it. For example, consider the following constant function f. By the law of excluded middle, Goldbach's conjecture is either true or false. If it is true then f is 1, and the required algorithm is just print 1. If it is false then the required algorithm is just print 0. In either case, there is a simple, one-line algorithm that prints f, so by definition, f is computationally decidable. It is true that we don't know which algorithm to use, but we do know that an algorithm exists. A slightly more complicated example is: the function f is computable because, by the law of excluded middle, there are only two possibilities to consider. For every positive integer n, the string appears in the decimal representation of. In this case, the algorithm that always returns 1 is always correct. There is a largest integer n such that appears in the decimal representation of. In this case, the following algorithm is always correct. Zeros in pi, n. If then return 0 else return 1. We have no idea which of these possibilities is correct, or what value of n is the right one in the second case. Nevertheless, one of these algorithms is guaranteed to be correct. Thus, there is an algorithm to decide whether a string of n zeros appears in. The problem is decidable. Criticisms: many modern logic systems replace the law of excluded middle with the concept of negation as failure. Instead of a proposition either being true or false, a proposition is either true or not able to be proven true. These two dichotomies only differ in logical systems that are not complete. The principle of negation as failure is used as a foundation for auto-epistemic logic, and is widely used in logic programming. In these systems, the programmer is free to assert the law of excluded middle as a true fact, but it is not built in a priori into these systems. Mathematicians such as L. E. J. Brouwer and Arend Hetting have also contested the usefulness of the law of excluded middle in the context of modern mathematics. See also, consequentia mirabilis, Diaconescu's theorem, intuitionistic logic, law of bivalence, law of excluded fourth. Law of excluded middle is untrue in many valued logic such as ternary logic and fuzzy logic, laws of thought, liar paradox, logical graphs, a graphical syntax for propositional logic, Park's law, another way of turning intuition classical, logical determinism, the application excluded middle to model propositions. Footnotes. References: Aquinas, Thomas, Summa Theologica, Fathers of the English Dominican Province, Daniel J. Sullivan, vols. 19/20 in Robert Maynard Hutchins, Great Books of the Western World, Encyclopaedia Britannica, Incorporated, Chicago, Illinois, 1952. Cited as GB 19/20. Aristotle, Metaphysics, W. D. Ross, Volume 8 in Robert Maynard Hutchins, Great Books of the Western World, Encyclopaedia Britannica, Incorporated, Chicago, Illinois, 1952. Cited as GB August 1 published, W. D. Ross, The Works of Aristotle, Oxford University Press, Oxford, UK. Martin Davis 2000, Engines of Logic, Mathematicians and the Origin of the Computer, W. W. Norton and Company, NY, ISBN 0-393-32229-7 PBK. Dawson, J., Logical Dilemmas, The Life and Work of Kierkegaard. Paragraph Dell, A. K. Peters, Wellesley, Massachusetts, 1997. Van Heijnut, J., From Frege to Gar. Paragraph Dell, A Source Book in Mathematical Logic, 1879–1931, Harvard University Press, Cambridge, Massachusetts, 1967. Reprinted with corrections, 1977. Lewitz and Ignatius Jan Brouwer, 1923, On the Significance of the Principle of Excluded Middle in Mathematics, Especially in Function Theory, reprinted with commentary, pages 334, Van Heijnut, Andrei Nikolaevich Kolmogorov, 1925, On the Principle of Excluded Middle, reprinted with commentary, pages 414, Van Heijnut, Lewitz and Ignatius Jan Brouwer, 1927, On the Domains of Definitions of Functions, reprinted with commentary, pages 446, Van Heijnut. Although not directly germane, in his Brouwer uses certain words defined in this paper. Lewitz and Ignatius Jan Brouwer, 1927, 2, Intuitionistic Reflections on Formalism, reprinted with commentary, pages 490, Van Heijnut, Stephen C. Klein, 1952. Original printing, 1971. 6th printing with corrections, 10th printing 1991, Introduction to Metamathematics, North Holland Publishing Company, Amsterdam, NY, ISBN 7204-2103-9. Neal, W. Neal, M. The Development of Logic, Oxford University Press, Oxford, UK, 1962. Reprinted with corrections, 1975. Alfred North Whitehead and Bertrand Russell, Principia Mathematica to 56, Cambridge at the University Press, 1962. Extremely difficult because of arcane symbolism, but a must-have for serious logicians. Bertrand Russell, An Inquiry into Meaning and Truth. The William James Lectures for 1940 delivered at Harvard University. Bertrand Russell, The Problems of Philosophy, with a new introduction by John Perry, Oxford University Press, New York, 1997 edition. Very easy to read, Russell was a wonderful writer. Bertrand Russell, The Art of Philosophizing and Other Essays, Littlefield, Adams and Company, Totowa, New Jersey, 1974 edition. Includes a wonderful essay on the art of drawing inferences. Hans Reichenbach, Elements of Symbolic Logic, Dover, New York, 1947, 1975. Tom Mitchell, Machine Learning, W.C.B. McGraw-Hill, 1997. Constance Reed, Hilbert, Copernicus, Springer-Verlag, New York, Incorporated, 1996, first published 1969. Contains a wealth of biographical information, much derived from interviews. Bart Kosko, Fuzzy Thinking, The New Science of Fuzzy Logic, Hyperion, New York, 1993. Fuzzy Thinking at its finest. But a good introduction to the concepts. David Hume, An Inquiry Concerning Human Understanding, reprinted in Great Books of the Western World Encyclopaedia Britannica, Volume 35, 1952, pages 449 ff. This work was published by Hume in 1758 as his rewrite of his juvenile treatise of human nature, being an attempt to introduce the experimental method of reasoning into moral subjects. Vol. I, of the Understanding, first published 1739, reprinted as, David Hume, A Treatise of Human Nature, Penguin Classics, 1985. Also see, David Applebaum, The Vision of Hume, Vega, London, 2001, a reprint of a portion of An Inquiry starts on pages 94 ff. External links, contradiction entry in the Stanford Encyclopedia of Philosophy.